we are going to solve another problem which is related to echelon and row reduce method. Last class we covered, we started with how to do the echelon and how to get the echelon matrix and row reduce method apply to the particular matrix. But in the last class, what we observed was all the constants were zero. Through that, you are able to derive the null matrix, right? But in this matrix, in this equation, if you observe properly, okay. So the previous problem was like ax is equal to 0 was there. Here, what we are considering is ax is equal to b. At the right hand side of the equation, we are considering some of the constants, okay. So we are what is your ux? What is ux? It's an echelon form. What is rx? It's a row reduced form, right? So we are going to calculate ax is given. We are going to calculate ux as well as the rx, okay. So the first equation is this: u plus 3v plus 3w plus 2y is equal to b1, okay. First three variables are u, v, w, and y is there. And second equation is 2u plus 6v plus 9w plus 7y is equal to b2 is there. Third one is minus u minus 3v plus 3w plus 4y is equal to b3. If you write this in matrix representation, that equation, if you write in the matrix representation, yeah, this is how it looks, right? So you are writing all the variables u, v, w, y here, and all the constants you are segregating. If you observe in the first column, all the entries are 1, 2, and minus 1. Same thing is there. All the constants we are writing 3, 6, and minus 3. Those things we are writing. And similarly, we followed 9, 3, 3, 9, 3, and 2, 7, 4, right? And also the constants we are written as it is: b1, b2, b3. What is our main aim here now? We have to calculate echelon matrix as well as row reduced matrix. And the column space obviously from this is all the possible columns what we got here, right? All these 4 columns exist in the column space, and also all the combinations of this and all the combinations, possible combinations also lies in the column space. Now what I see, this is one thing you should observe. You can also write this matrix that 1, 3, this a and constants you can write together, no problem. Or else you can write a line here, you write a line here, and you can combine, okay. See, since everything is a variable, other things are variable, we are considering only the constants in this. The constant in this, in the given equations are this thing as well as this thing, right? So you can write the same thing here. Now you apply. If you observe this matrix properly, actually this is the same matrix which I took for the previous case, same thing. Here, if you observe this properly, now I have to apply row reduce method. Here in the first element is 1, the second element is 2. So you can subtract 2 times with respect to the row 1, that gives 0 here. Here minus 1 is there. In order to make it as 0, you subtract, you add with the first row, it is 1. So when you add minus 1 with the 1, this becomes 0. So these 2 things you have to do now. So row 2 will be row 2 minus 2 times of R1, and row 3 will be row 3 plus row 1. That is what we are doing. So now what we are doing is 2 substitute here, 1 is here, 2 minus 2 is 0. That is what I am writing here. Now you substitute 6 here, then 3 here. So 6 minus 6, again it becomes 0. 9 here, R2, and the corresponding R1 element is 3. So 9 minus 2 times of 3, it's 6, it's 3. 9 minus 6 is 3. Again you have 7, substitute here, 2 here. So 7 minus 4, it is 3. So that is what we got. And meanwhile, what is B, R2? You have to write R2 minus 2 times of R1. So R2 is B2. 2 times of R1 corresponding element is B1. So B2 minus 2B1 we have written. So again, what we do here is, what is a one more thing what you can do is, in the row 2, if you observe 3, 3 is there. in the row 3 you have 6 is there. So what you can do is you can subtract row 3 by 2 times of row 1. So row 3 is nothing but row 3 minus 2 times of R2. So R3 is 6, 2 times of R2 is 3. So it becomes 6 minus 6, the value will be 0. Similar to that, you'll get a 0. But what about this side? What you get is, so already you have B3 plus 1 here. Okay. Now again you are subtracting with 2 times of R2. So B3 plus 1 I have written minus 2 times of B3 minus 2B1. So if you solve that, what you get is B3 is there. So B3 will remain as it is. Whereas you have B1 here is there. Here else again B1 is there. It becomes minus 2 into minus 2. It becomes plus 4B1 plus B1 is 5B1 will be there. And minus 2B2 will be there. So this is what we got. So after reducing from the previous step, this is what we got, right? So I have written the same thing in the matrix, including these variables. I have written this, and this is an example. Okay, it's not a question. Here, what we are substituting is we are substituting the values of B1, B2, B3 for a particular case we are considering. Okay. Up to now, we have considered as a general case, B1, B2, B3 like that. What if B1, B2, B3 is 1, 5, 5. B1 is 1, B2 is 5, B3 is 5. Okay. Now, what happens to this equation? So, for this specific case, substitute B1. B1 becomes 1. What about B2? If this is 5, this is 1. So, 5 minus 2 is 3, right? And substitute this also. What you get is 5 minus 2 times of 5 minus 10 minus 5, so plus 5. You can substitute that. Here, this is not u of x, okay? If you observe this properly, this one I have written as ax only, the actual matrix what they have given. In the starting, what we have written was a into x into b is equal to b, right? So b was b1, b2, b3. Now, since they have given the special case 155, I have written this. Now, so as I discussed, you substitute this 155 in the u of x, okay, like this. If you substitute 155 for this equation, what you get is this is 1, b2 is 5 minus 2 times of 1, it will be 3, b3 is 5 minus 2 times of 5 means 5 minus 10, it is minus 5 plus 5. So it becomes 0, right? So after substituting, you got this. So this is what you got, the specific case of u of x. So you got at the right hand side, it is 1, 3, 0. Now what you do is, see, observe this matrix carefully, okay? So this matrix carefully. Now you have to do the back substitution. So multiply, okay? See here, what I have written is the first, I'm doing the matrix multiplication, multiplying this with this first row with this column elements. But what I'm doing is I'm coming from the bottom, okay? So u, v, w, y multiplied by this third row, everything is 0, so nothing you get. When you multiply this with the second row, what you get is u anyhow is 0, v is 0. Then when you multiply, this becomes 3w and 3y you will get. 3w and 3y you will get. So that is there. And what is the second element? It's 3. So is equal to 3. Similarly, what you get from the first one, it is like, 1u, 3v, 3w, 2y is equal to what? 1. So this is what I have written here. If you observe this, yeah. So that is what I have written here, these two equations. And one more observation what you make is, I already discussed in the previous problem also. What are the pivot variables here? This is one of the pivot variable, as well as this one is the pivot variable. The first element in the first row is 1. the first element in the second row is the other two are 0. The first element starts here is 3. So only 2 pivot elements is there, whereas in the row 3 nothing is there. So 2 pivot elements that exist in the row, column 1 as well as column 3. That means it corresponding to the column 1 and column 3 is nothing but corresponding to the variable u and w. Okay, so u and w are pivot variables, whereas v and y are free variables. So that is very important. Okay, so v and y are free variables. From this equation, if you see it, once you get this equation, you express pivot variables in terms of the free variables. So what is w? So 3, if you take the common factor, 3 goes up, goes out, and you'll get only 1. So w is equal to 1 minus y. And similarly, if you observe this one, so you substitute for w also. You can substitute for w. What is the substitution for w? It is 1 minus y. You substitute like that. Then you'll be left with only 3 variables. U, v, and y will be there. Since you are substituting w is equal to 1 minus y. If you solve the equation, you get this. U is equal to minus 2 minus 3v plus y. This is the equation you get after solving that. So u and w, they are pivot variables, whereas v and y are free variables. So you are expressing pivot variables in terms of the free variable. That is very important. So u and y are free variable. Double infinity of solutions, basically what they mean is, since there are 2 free variables, okay, since there are 2 free variables that you can observe here, the solution what you get is, you vary v from 0 to infinity. That is also possible, you keeping this as a constant, and either you vary this value by keeping this as a constant. So that's why double infinity of solutions. You have a double infinite solution. Since v and y are free variables as well as they are real, you have infinite possible numbers of solutions are there. Okay, so what you did up to now, so you expressed pivot variables in terms of the free variable. Now this is very important. Okay, if you observe this, so we have these variables u, v, w, y. These variables are there. Now what is u? U is nothing but minus 2 minus 3v plus y. So minus 2 is constant. With v I can write minus 3, and y, with y I can write 1. Okay, so that is what I have written. The same equation, if you multiply, you will get the same equation only. This equation only you will get u minus 2 minus 3v plus y. Okay, same thing is there. I have written in the matrix representation. That's all. And v is a free variable. Since v is a free variable, you don't have any substitution for it. So the constant is 0, and whenever the v position, it becomes 1. In y position, it becomes 0. And similarly for w, what is w? 1 minus y is there. So you have 1 as a constant and minus 1 as a coefficient for y. There is no coefficient for v. So for v, you are writing 0. For w, for v, you are writing 0. For y, since from this, it's minus 1 is there, so I am writing minus 1. Similarly, for last variable y, what you are writing is, that is also a free variable. So you don't have a constant, as well as you don't write in terms of v also. It exists only at y. So you are writing 1 here. So basically what you are doing is, you are expressing this in terms of a matrix representation. Since v and y are free variables, that you'll get only 1 at v whenever there is a v is there. And if for y, you'll get y. In y position, you'll get 1. And you already have minus 2 minus 3 1. So that is what I am writing, minus 2 minus 3 1. And for y, I am getting 1 and minus 1 for y. So that's why for w, I am writing 1 and minus 1 for w. So this is what, if you have remembered the previous problem, this is what we got, right? Only these 2 things we got in the previous problem, because it was in the format of ax is equal to 0. In this problem, it is in the format of ax is equal to b, right? Some constant is there in the right hand side. That's why you are getting one more matrix here. In previous problem, we got only these two. In this problem, we are getting this also. So this is, we know already, it's a special special columns, special matrix or special solutions. Combining these two gives the null, right? Null space. Combination of all these two gives the null space, right? So that is Xn. This solution is called as a particular solution. Okay. This solution is called as a particular solution that is represented by xp and xn. In order to get the complete solution of a particular equation, you have to find both. If you find, you can easily find, you can represent, if they give the equation like ax is equal to b, you consider it ax is equal to 0 and solve, you'll get only this x of n. Then including that constant, this you'll get the particular solution. Adding both, you'll get the complete solution. See, if it is lesser number of matrices, you can easily find out. If more and more number of dimension is there, if it is 10 cross 10 matrix, 20 cross 20 matrix, you can easily write in the programming language. So that is the one of the beauty of linear algebra. Okay, since the computer science is dominating everywhere, it is software. So this you can write, or you can create an automated version of it to calculate the solutions of a particular equation. In that way it helps. So you calculate the x of n, then you calculate the particular solution. Combining that gives the full solution. So it's calculating this xp is also very easy if you follow this. First find out the echelon matrix, then you find out the row reduced method, then you find like that. If you follow the procedure, it becomes quite easy. So this is nothing but for a particular equation. So one of the takeaway from this is, whenever x of a of x is equal to 0 is there, you'll get only the null space. Special cases, whenever ax is equal to b, you'll be having a particular solution as well as the null. X of n and x of p will be there. Combining that becomes x. That is a complete solution. So this is what we observe. xp is nothing but x particular. Xn is nothing but x null space. Okay, xp is a particular solution to ax is equal to b, that I already explained. So these are all the steps you should follow to solve the particular criteria. Reduce ax is equal to b to ux is equal to c. That is what you should do. Then with free, if you make free variable is equal to 0, you'll get the particular solution, right? You make free variable is equal to 0 in the particular equation, you'll directly get the particular, this part you'll get very easily. We'll see that in a problem. Okay, and find the special solution. Okay, so you express ax in terms of ux, then rx, then you find out the particular solution by substituting free variables is equal to 0, then you calculate the special solution, that means null space. So what they're telling is, you calculate in the third step, you calculate this, in the second step you calculate this, add those two, you'll get the final step. Okay, so this one we saw only, we have not, ux is equal to c, we got it only in the echelon form matrix. We have not reduced into reduced echelon matrix format. So I have taken the same example from the previous slide. I have copied this, right? The same thing I have written here. Okay, so you know that you can write the matrix representation like this. So same thing, whole thing is there, 1 3 3 2, all matrix has been copied, and this constants is written here, same as it is, like that. Then in order to express in terms of a reduced echelon form matrix, what you should do, some of the conditions are like, pivot variable should be 1. So this pivot is 1 finally, but this one, the second pivot is not 1. So you have to make it as 1. In order to make it as 1, you have to substitute R2 is equal to R2 divided by 3. So divide row 2 by 3. What you get is, when you divide row 2 by 3, you'll get all the 3 becomes 1, right? So R2 becomes R2 by 3. Then one more thing. After that, what is one more thing what you should do is, in order to express in reduced R of x format, what you should do is, above the pivot, nothing should be, everything should be 0. Here, above this pivot, nothing is there. Whereas in the second row pivot, you have a 3. So you have to make it as a 0. How do you make it? So subtract row 1 by 3 times of row 2. So subtract row 1 elements by 3 times of row 2. See, it will not affect these two. It only changes other 3. Okay, so it will not change the pivot. So you subtract this 3 minus 3 times of this, so becomes 0. So similarly, you substitute, R1 is 2 minus 3 times of R2 is 1. So 2 minus 3 is minus 1 you'll get here. And again, here 1 is there. So substitute that. No, here. Yeah, 1 is there. You substitute that. Minus 3 times of R2, it's 1 is there. 1 minus 3 is nothing but minus 2. That is what you got here in this equation. Okay. So after applying this R2, R1, yeah. So after reducing into echelon form, row reduced form, we got this, right? This is the matrix we got actually. Both the pivot variables are 1. Above the pivot variable it's 0. Then you are using the same case, multiplying that and equating to the right hand side, right? So this is the row reduced Rx format. See, you get whatever the solution you get, Ax is equal to B. If you try to solve Ax is equal to B, you'll get the same solution. And similarly for Ux as well as for Rx. Okay. So one more observation what you make is, already you know that, so actually these two are 0, correct? No, these two are 0. When you observe this, what you can make is, in this matrix, number of non-zero elements, non-zero rows are how many? In these 3 rows, number of non-zero rows are 2. First row and the second row. Similarly, in this also, number of non-zero rows are first row and the second row. So that is nothing but the rank of the matrix. Okay, that is nothing but a rank of the matrix. Or else the number of pivot variables. This is already, right? Number of non-zero rows gives the rank of the matrix. One more thing, what you can do is, if R pivots are there, then the rank of the matrix is R. Okay, based on the number of pivots, you can write the rank of the matrix. So that's why rank of the matrix is 2 for this example. Okay, again we'll solve the next problem. Okay, you understand this, so you understand if you understand this problem, it means that you understood all the whatever I have taught up to now, everything you can if you understood this, that means that you understood all the concepts. Okay, try to understand this. This problem contains all the things whatever I have explained up to now. So the question is this: Ax is equal to B is the format. The equations are 3 equations are given. One is 1x1 plus 2x2 plus 3x3 plus 5x4 is equal to B1 is there. Then 2x1 plus 4x2 plus 8x3 plus 12x4 is equal to B2 is there. And the third one is 3x1 plus 6x2 plus 7x3 plus 13x4 is equal to B3 is there. So the first question is this: reduce AB to UC. That means you reduce this Ax is equal to B into U of C. U of C is nothing but echelon matrix, right? To reach the triangular system. So upper triangular format you have to express. First thing is you have to calculate the echelon matrix. What about the second one? Find the condition on B1, B2, B3 to have a solution. So here you have a B1, B2, B3, okay? So you'll reduce using row echelon matrix. Then what is the condition the B1, B2 and B3 should have to have a solution for this equation? Okay, so I'll repeat again. Here what they're asking is, for what condition of B1, B2, B3 this solution exists. Okay, if B, whether B, all the 3 should be equal, like that, some condition you should find out. For that, the solution should exist for this case. Then the third one, describe the column space of A, which plane, which is in R cube. So you have to find out the column space of A. Okay, you have to describe that. And describe the null space of A. special solutions in R4. Okay, you have to find out the null space. Okay, I have given one statement like, you know, number of equations and number of unknowns with respect to the null space, and if you have remembered, okay, that you can observe in this question. So you have to calculate the column space, another one is a null space, and the fifth question is find the particular solution to ax is equal to 0 comma 6 comma minus 6. That means the values of b1 b2 b3 are 0 6 and minus 6. They are giving a specific case for b1 b2 b3, and you have to solve for it. Okay, and the complete solution, you have to find out the particular solution as well as the complete solution. Okay, complete solution is xp plus xn. Xn you got it from the null space, xp you have to find out. Okay, then what is the last part is this, reduce u of c to r of d. So you reduce the echelon matrix to the row reduced echelon matrix. Okay, so this is our problem. Okay, see, nothing difference is there, same thing, only try to understand this properly. Okay, so it becomes a repetition. So a of b is given, I have written that in the matrix representation. So 1 2 3 5 2 4 8 12 3 6 7 13. Okay, constants also I have written together. Now what is the condition now? First row element is 1, I have to make other two as 0. So other two are 2 and 3. So you subtract row 2 from 2 times of row 1, row 3 in term 3 times of row 1 you do it. So row 2 is row 2 minus 2 times of row 1, and row 3 is row 3 minus 3 times of row 1, that you do. So I have written the row 1 as it is, 1 2 3 5 and b1. So what I should do according to this, row 2 should be row 2 minus 2 times of r1, row 1. So row 2 is 2, row 1 is 1, so 2 minus 2 is 0. 4 you substitute here, and 2 in r1. So 4 minus 2 times of 2, it becomes 4 minus 4, that becomes 0. Again you have 8 here, substitute 8 here, and you have 3 here, substitute here. 8 minus 2 times of 3, that means 8 minus 6, that means 2. And similarly 12 you have here, 12 minus 2 times of r1, 2 times of r1 is 5, 12 minus 2 times of r1 is 5, so 12 minus 10, it becomes 2. Similarly go to the third row, 3 substitute here, minus 3 times of 1, so 3 minus 3, it is 0. 6 minus 2 times of minus 3 times of r1, so 6 minus 3 times of 2, again it becomes 6 minus 6, it becomes 0. Then 7 here, 7 is there, here you have a 3, 7 minus 9, it is minus 2. 13 is there, here it is 5, 13 minus 15, it is minus 2. So similarly the b2 becomes b2 minus 2 times of b1, b3 minus 3 times of b1, that is that. See here, all these things are coming very easily. You have to pick some of the problems from mathematics, then you have to try to do the row reduction if it is a difficult. Okay, these two problems are from picked from the prescribed textbook only. Okay, most probable chance is there that you may get this type of question only, but almost so many times it may be a difficult to reduce like this. Okay, you'll not get direct answers like this maybe. Okay, you try to solve those kind of problems also. And here, okay, so next step is this. So we got this. Now what I'm doing is, so I have in the row 3, if you observe minus 2 is there, row 2 it is 2 is there. So what I can do is row 3 I can add a row 2 and row 3, so it becomes minus 2 plus 2, it becomes 0 here. So minus 2 plus 2, it becomes 0 here. So again we added these two, so that's why b3 minus 3b1 plus b2 minus 2b1. So that if you add it, what you get is b3 plus b2 minus 2b1 minus 3b1 is minus 5b1. That is what you get. And one of the observation what you observe now very carefully. So see here, if you write all the equation here, variables here, if you multiply, what you get is if you have x1 x2 x3 x4 here, or u v w y, If you multiply some variables is there is equal to b1 you'll get. Again here you'll get w and y is equal to b2 minus 2b1 you'll get. Whereas in the last case what happens is left hand side is 0, right hand side something is there. So that is not at all possible, right? In mathematics, if left hand side is 0, right hand side should be 0. So that's why you have to consider this b3 plus b2 minus 5b1 is equal to 0 in order to have this condition 0 comma 0, 0 is equal to 0. So in the second question what they've asked is what is the condition for b1 b2 b3 to have a solution, right? In order to have the solution from this matrix, you can observe that when you multiply the variables with the last row, you'll get left hand side is equal to 0, right hand side will be b3 plus 2b2 minus 5b1. So that is not highly impossible. So what you do is you equate this to 0. So that you get a 0 is equal to 0 format. So this is the condition it should follow. So this is the condition it should follow in order to have a solution. Okay, b3 plus b2 minus by 5b1 is equal to 0. That is a condition the constant should follow in order to have a solution. Okay, and the next third question was like, you have to calculate the column space. Okay, you have to calculate the column space of A. If you observe this properly, column space of A is the plane containing all the combinations of pivot columns. Okay, very easy, right? So, and the matrix UB, what you have is pivots are at column 1 and 3. So columns 1 and 3 of AB is in column space. So when you observe this, so after a row reduction method, we observe that there are how many pivots are there? 2 pivots are there. The first row, first element, non-zero element in the first row is 1. First non-zero element in the second row is 2. So from the pivots, we got the columns, right? So from the pivots, we got the columns. Now, the next is they are asking for null space. Okay, null special, columns. Here the thing is, in order to find out the null space, from the definition of the null space itself, you have to find out the solution, all the possible solutions for Ax is equal to 0, right? From u of ub, you have this. This is from the previous slide. But what we should do is, in order to find out the null space, you have to make everything this right hand side is equal to 0, right? We have to make all the right hand side is equal to 0. So that becomes 0, 0, 0. Okay, now? So once you make this as 0, so now you try to reduce it and try to find out the special case of it. Okay. So we have this from this. Now you express in terms of a row reduced method. So we have this in this pivot variable is 1. Here the pivot variable is 2. So one of the condition to find out the R of X is you have to make a pivot values is equal to 1. So that's why what I'm doing is row 2 I am dividing by 2. So I made it as 1. Okay, row 2 2 2 0 becomes 1 1 0. The first row element remains as it is 1 2 3 5 0, and the third row everything is 0. Okay, and one more observation what you should make is in order to express into row reduced form, the above the pivot everything should be 0. Here nothing is there, whereas in this pivot above that 3 is there. So you subtract row 1 from row 2 3 times. So row 1 minus 3 times of R2. Anyhow, here nothing will change. 1 minus 0, 2 minus 3 times of 0 is 2 only. Whereas here 3 minus 3 times of 1. So here 3 is a 3 minus 3 times of 1 becomes 0, right? 3 minus 3. Similarly here 5 minus 3 times of 1, it becomes 5 minus 3, it becomes 2. So this is what we got finally. Now this is very important. So now what we got is this. Now we got this Rx is equal to 0 format. You write all the possible, try to write in the matrix representation format. So matrix is A is these 4 columns. That means 100, 200, 010, and 210. That is what I am writing. The last column is nothing but a constant, right? So I am writing here. The variables I am writing as x1, x2, x3, x4. When you observe this, you have to find out which one is free variable and which one is a pivot variable. So that is how you will calculate the null space, right? So pivot variables are lies in the, this is the pivot variable as well as this lies in the first column as well as the third column. So that means that this first element and the third element is a pivot variables, whereas second column element and the fourth column elements are free variables. That means x2 and x4 are free variables, x1 and x3 are pivot variables. Now what you should do, you have to express x1 and x3 in terms of x2 and x4. Try to write this equation. What you get is x1, 2x2, 0x3 and 2x4. So that is what you got is equal to 0 anyhow, because this is 0. So in the second equation, what you get, x1, x2 is 0, x3 and x4 you will get, and that will be equal to 0. Whereas in the third row, everything is 0, nothing you will get. Now what you should do, you have to express x1, x3 in terms of x2 and x4. You express x1 in terms of x2 and x4. What you get is x1 is equal to minus 2x2 minus 2x4. And you express x3 as what? Minus x4. Okay. Now the next step is very important. Now what you should do is, now you try to find out what are these things. Okay. If you try to analyze now, x1 is nothing but this, x2 is nothing but x2 only, whereas x3 is nothing but this, x4 is x4 only. So that is what we are going to write now. So if you observe this properly, so x1 is, this is what we got, minus x2 minus x4. x2 is what? x2 only. x3 is, we got it as minus x4. x4 is x4 only. x2 and x4 are free variables. That's why you get the same thing. Whereas x1 and x3 are pivot variables. So you got something here. Now, if you observe this part, only you have free variables here, right? When ax is equal to 0 format, you'll get only the free variables. If you observe this properly, so you have two variables here, x2 and x4 is there. So what are the things comes under x2? x2. What are the things? In the first row, you have x2. So what is the coefficient? Minus 2. So you write here. In the second row, you have x2. What is the coefficient? It's 1. So write here. In the third row, you don't have any x2. So write 0. In the fourth row, you don't have x2. That's why write 0. Similarly, x4. What is in the first row? You have, what is the coefficient of x4 in the first row? It is minus 2. Right here. x2 in the second row, x2 is there, x4 is not there, so write 0. In the third row, you have x4, but coefficient is minus 1, so write minus 1. In the fourth row, x4 is there. What is the coefficient? It's 1, so write this. Okay, now, so this is nothing but a null space. Combination of these two is nothing but a null space. Okay, that is what you have to calculate the null space. So what we did, first try to express Rx is equal to 0. Then you try to express pivot variables in terms of the free variable and write the answer in the matrix representation. Separate out the free variables. Those columns, what you get is nothing but a null space. And the fifth question is this. In the question, what they have given us, they have given the specific value of B. The specific value of B is 0, 6, minus 6. Okay, that is a specific value they have given. And echelon form matrix is this. I have taken from the previous slides. I have directly taken that because since we already proved that. So echelon form is this. Now the condition is this. So substitute B1 is equal to 0. So 0. Then again substitute B2 is 6. B3 is minus 6. B2 is 6 minus 2 times of B1. B1 is 0. So 6 minus 2 times of 0 is 6. And the last one is B3 is minus 6. B2 is 6. 6 minus 6 is 0. Anyhow, B1 is 0. So 0. So after substitution, you got this. Okay. So after substitution, see in this question, what they are asking is, in the fifth sub question, what they are asking is, you have to find the particular solution by substituting B1, B2, B3. As you all know, overall solution is nothing but sum of particular solution and the null space, right? We already calculated the null space, it's common. For a particular case 0, 6 and minus 6 as B1, B2, B3, now we are calculating the particular solution for it, okay? So we got this. So this is the format we have now, but B1 is 0, B2 is 6 after substituting, okay? Now I express this in matrix format, right? Anyhow, it is there in terms of variables, okay? So this part is A, I'm writing that. And you have 4 columns, right? That's why you have to write the 4 variables here, x1, x2, x3, x4. And right hand side, you have 3 values, right? So since there are 3 rows, obviously you'll have 3 values, okay? From this, what is the conclusion you can make from this is, so free variables are x2 and x4, correct? No? And I have given the definition saying that, in order to find out the particular solution, you have to substitute free variable is equal to 0, okay? So make this free variable is equal to 0, x2 and x4 is equal to 0. Now you multiply with the equation. So whatever the solution you get, that is a particular solution. So I have multiplied with respect to the matrix, okay? So here I have multiplied here, x1 in x1 plus 2x1, matrix multiplication I did, 2x1 plus 3x3 plus 5x4 is equal to 0. And the second row is 2x3 plus 2x4 is equal to 6. Like that I did. So this is what you get. Okay, this is what you get. These 2 equations you get, but you know that in order to kind of find out the pivot variable, particular solution, what you should do is you should make free variables as 0. So you make these 2 is equal to 0. When you make these 2 is equal to 0, x2 is equal to 0, x4 is equal to 0. So substitute x4 is equal to 0. What you get? So you get is 2x2 is equal to 6 from the equation 2. Yes, x4 is 0. So 2x2 is equal to 6. So 2x3 is equal to 6. So x3 is what? 3. And again, from the next equation, what I did is, from the first equation, again I substituted x2 is equal to 0 from the first equation, right? From the first equation, I substituted x2 is equal to 0 here, and x4 is equal to 0. You are left with what? x1 and 3x3, x1 and 3x3, but x3 is what? From the previous equation, we got 3. So substitute that, x1 becomes minus 9. Now write in the matrix format. So this is what we got. Particular solution is nothing but what? Particular solution of is nothing but xp plus xn. But xp is nothing but x1 we got it as minus 9. X2 and x4 is 0 for a particular solution because of the free variable, whereas x3 is 3. So if you substitute that, this column elements are particular solution. So previously we calculated the null space, special case, right? Now we calculated the particular solution, okay, for this case. Now what you should do? What is the last question? You have to find out the R of x. From the U of x, you have to find out the R of x. So as usual, it's easy. So I have written this with this specific case. For this specific case, I have considered this. So what is the thing in order to find out the R of x? One is the pivot variable should be made it as 1 and above things should be 0. So the same thing we have done here. So previously, as I previously explained, this should be divided by 2. So if you divide by 2, this becomes 1, 1. Then again, the top element, you should make it as 0. The same thing you apply to this case also. So first one was, 6 divided by 2, it has become 3. The another one is R1 will be R1 minus 3R2. That means R1 is 0 minus 3R2, it becomes 9. So this value also changes. We solved the same thing, but this elements was 0. Here something is there. So this is R of D. Okay. So this is what the conclusion. Okay. This is all about. This is related to echelon form matrix. This is related to the row reduced form. if you observe that echelon form matrix, this is an example for 5 cross 8 staircase pattern. So this dot, the dark dot is nothing but a pivots. Okay, starting non-zero element in a particular row. In the second row, this is the non-zero element. In the third row, this is, because all these three are zero, the first non-zero element is this. In the fourth row, the last element is non-zero, that itself becomes pivot. In the fifth row, everything is zero. So 4 pivots are there. This star represents any value. Okay, below that, everything should be zero. This is the actual format of echelon U, format of U. Reduced form, all the values, these pivot values should be 1. So that is what they have written, 1 1 1, and above this pivot values everything should be 0. Okay, above this pivot element everything should be 0. This is the format of R. So this is the example. Okay, so these are all the assignment questions. Okay, I wanted to just give some idea about the second one. Okay, since the second one or third one, okay, I'll pick the third one only. Here, if you observe this, this is the assignment question. Reduce A and B to echelon form to find their ranks. Which variables are free? So you have to express A and B in terms of the echelon form, and you have to find out in the first matrix, since you have a 4 columns, you'll get a 4 variables. Out of that, you have to find out the free variable. And in the second one, you have a 3 cross 3 matrix. In this, you'll get a 3 variables. So you have to find out which one is free. And also you should find out the special solution. How do you find out the special solution? You make AX is equal to 0 format, find out the null space, that becomes the special solution. Okay. So in this second one, it is 2 cross 4 matrix. Number of variables are 4, but right hand side you will be having B1 and B2. See, in the second example, we found one condition, right? For the third case, the third row was 0. In the right hand side, B1 minus 3 B2 for plus 5 B3 is equal to 0. That condition we found out in order to find the solution for this equation. Similarly here, for A and B, you have to find out the condition for B1 and B2 such that solution exists for A. Okay, so that is what you have to find out. Find the echelon form first, then find the free variable and the special solution, and also find the condition for, and also find out the complete solution. Okay, you find out the complete solution. So once you find the special solution, make free variable is equal to 0, you'll get the particular solution. You add particular solution and the special solution, that becomes the final this thing. So I want to give some hint about this problem. Find the complete solution of mx is equal to b. Only the starting part I'll explain this. Okay, so in this yeah, no, not this. So this is the question, right? So what they have given is they have given this. Only thing I wanted you to understand is it's only 2 variables you should take, right? Because it's a 2 column. Don't take 4 variables. Okay, you take 2 variables. In the right hand side, you have a 4 values, right? Now, if you try to reduce into echelon form, right? See, the first elements itself 0. You don't get any pivot. Okay. Whereas in the second element, if you can subtract the 4th row with the second row, right? So 4th row also becomes 0. So only you are left with only second row. That in that only you have a 1 pivot. 1 pivot will be that. That's all. So this is how it looks. Okay. So what you can do in order to find out, they are asking for a particular solution. In order to find out the particular solution, what you should do is one of the condition is you have to make these 3 free variables is equal to 0, and you calculate, that gives the particular solution. And you make these, all these 3 is equal to 0, then find out the null space. Okay, this is how it looks. The particular solution will be this, b2 comma 0. And similarly, if you try to calculate the special solution also, see, everything has become 0, right? If you try to calculate the special solution also, it is like this. So you'll be getting -2 and 1. So that's all for the day.